For part A, we need to find the x-intercepts and the y-intercepts. So the y-intercept is simply when x is 0, and that gives us just this number by itself here, minus 3. Now we want the x-intercepts. That's going to be when this thing is equal to 0. And so to get that, we can try and factorize the expression and then set it equal to 0. So for this to work, I'm going to need a 2x and an x, and then I need a 3 and a 1. If I put a 3 on the right-hand side, I'm going to get 6x. It's going to be too big. So I'm going to put 3 here and 1 here. If I make this a minus and this a plus, then I get minus 3x, I get plus 2x, and it does indeed work. So my x-intercepts are going to be minus 1 or 1.5. And now we've got the information we need to be able to plot this. It doesn't say put the turning point in, so I think let's leave that out. It's not necessary. If you put it in, that's fine. So we know it crosses there at minus 1, we know it crosses at 1.5, and then we know that it crosses at minus 3. The turning point is going to be halfway between, so it's going to be to the right of the graph, so I should try and just illustrate that. There we go, it's not bad. So make sure that the turning point is over here, it doesn't just turn at this point here. I don't think you get penalised for that, but it's just good practice to have show this understanding. Okay, so that is, I should just label X and Y, but that is part A sorted. Hence, or otherwise, solve 2x squared minus x minus 3 is less than 0. So we've drawn the function of y equals 2x squared minus x minus 3. So where is it less than 0? It's all along here. But if we come back to just the inequality, we're just interested in the x values for which this thing is less than 0. So we see it's everything between here, and our value for, our answer for part B is simply going to be that minus 1 less than x less than 1.5. Finally, given that the equation 2x squared minus x minus 3 equals k has no real roots, find the set of possible values of k. Two methods for doing this that I'm going to talk about. First method is to consider this that these are simultaneous equations. I've got the thing on the left is y, and consider as y equals 2x squared minus x minus 3, and the thing on the right I can say that it's y equals k. Now I can imagine moving this up and down. If I move it up, here I've got 2 roots to the simultaneous equation. As I move it down, I've still got 2 roots. On the turning points, I've got a repeated root, and as I go below it, that's where I've got no roots. So I want to find out where this turning point is, and then that's basically going to tell me where I go from having 1 root to having 0 roots. So let's have a look at this. Okay, so I would find dy, but I mean you can complete the square, but it looks like quite an awkward one to do. So I think doing dy by dx will be a good idea to find the stationary point. So that's going to be 4x minus 1, and that's going to equal 0 for the minimum. We know it's a minimum in this case. And that's going to mean that x is a quarter, and I can substitute that back in to find the y value, and this is minus 25 over 8. Okay, that you're squaring a quarter and everything, you get quite a horrible fraction, but hey, that's what it is. So that means that this is this point here that I've just illustrated, and so if k is less than that, if k is equal to it rather, then we're going to get 1 repeated root at that point. If it's greater than it, that's where we're going to get 2 distinct roots. If it goes below it, that's where we get 0 roots. And so the answer for part C, we've shown our working on the right, is going to be that k has to be less than minus 25 over 8. Now that is one way of doing it, and you might be happy with that, the graphical method. I think it's quite a nice, quick method. Let's just look at a second method for doing it, and that would be, so method 2. Method 2 would be to take this equation I didn't mean to take the h with it, and rearrange it into a quadratic. So I can write it as 2x squared minus x minus 3 minus k, which I can write as minus 3 plus k, equals 0. Now I'm interested in where there are no real roots. So no real roots implies the discriminant is less than 0. So that means b squared, which is minus 1 squared in this case, minus 4ac, 4 times 2 times minus 3 plus k is going to be less than 0. So 1 minus 1 plus 8 3 plus k is less than 0. So 1 plus 24 plus 8k is less than 0. 8k must be less than, so that was a plus there, minus 25, and we get that k is less than minus 25. Exactly the same answer, of course it has to be, but just a different way of doing it.